everyone. I can't. It won't let me unless I connect to the internet, and the internet is not working. Yeah. This was as close as I could get to full screen. Okay, so hey everyone, I'm very happy to be here, and I also want to kind of thank all of the organizers. So far from what I've seen, this event is a great opportunity for everyone. Here, certainly for us, more and more of our team will be filtering in over the next week or so. So really looking forward to everything happening. So I'm going to talk about how to use options as building blocks. This is a concept that exists, in finance, independently of Web3, but its power is kind of amplified in the context of Web3, and so I'll dig into that during the course of our talk. So I'll give you a little background about myself and Arrow Markets. So I'm the co-founder of Arrow Markets. I have a background in math and economics, did my PhD in finance, and then started just building things in Web3 a couple years ago, and just kind of fell in love with it and haven't looked back since. My co-founder, Ed Merez, has a similar story. So I'm really excited to kind of continue to dig into this space. So I'm going to also tell you a little bit about Arrow Markets before I dig into how to use options as building blocks. So in fact, Arrow Markets is named after, our namesake is the Nobel laureate economist Kenneth Arrow. And Ken Arrow had this very powerful result dating back even as far as the 50s, that you could use options as these building blocks to reconstruct essentially any type of payoff profile that you would want. And so we really, this kind of idea really animates what we're doing, and that's why it kind of makes sense that it's our namesake. So what I want to do in this talk is just kind of walk through some very simple examples of how to use options to build up different types of payoff profiles, and then how to use the Arrow SDK to actually implement those portfolios. First, quickly, I will talk about how, what some of the challenges are in building options in Web3. It is a non-trivial task. The options in Web3 haven't completely taken off yet. And there are some real serious technical challenges associated with building this technology out. So here I just want to talk about, at a high level, some of these trade-offs. So one trade-off is between AMMs, so automated market makers, and limit order books. So one advantage of a limit order book is, price discovery operates in this very nice way, but you need to have sufficient liquidity on the buy side and the sell side in order for the price discovery to work. So for a particular asset, you need a lot of interest. You need a lot of people coming in, making bids and asks in order for the price discovery to operate. You can do an AMM in a way that does not rely on that kind of targeted liquidity. So that's something that we take advantage of. Another kind of high-level trade-off here is with regards to how you do settlement. So at a high level, there are kind of two ways that you could do it. The way it's happening in centralized markets is very much this kind of bilateral enforcement way. So you match counterparties to particular contracts, and then you need some mechanism for dynamically enforcing the liabilities that are created in that system. So, margin calls. Another way to do it, the way that we do at Arrow, is doing a peer-to-pool model. The disadvantage of the peer-to-pool model is you need to take some steps to hedge the risk that the pool is taking on in that context. And so there are a bunch of challenges with doing that. Arrow did take this approach, as I've alluded to. So Arrow Markets uses an indifference pricing based AMM in a peer-to-pool model. The contracts run on an EVM. So right now we're just live on the Avalanche the Avalanche testnet. So it's like the C-chain testnet, Fuji. And we have custom oracles that facilitate the indifference pricing calculation. So a lot of these calculations that need to be done for this AMM are fairly sophisticated. So we need to interact with some off-chain resources to make that happen. I want to say a little bit more about the AMM, but it's not really the focus of this talk. So, we have put a lot of work into thinking about how this indifference pricing mechanism works. And so I would encourage any of you who are interested in those details to reach out to me or any of the team, or go to our website or our Discord channel and ask questions there, because a lot of work went into that. But for the purposes of this talk, I'm going to be kind of taking the prices as given. So assume we have some options that we're able to create and price. How can we use those to form portfolios that replicate other types of payoff profiles? So earlier, there were a few people talking about exotic derivatives, structured products, and so forth. So all of those things you can reconstruct using portfolios of options. And so that's kind of what I want to focus on for this talk. But again, to the extent people are interested in learning more about the indifference pricing AMM, please reach out to us. Okay, so I talked about this. So one advantage of the AMM we have, again, is that price discovery does not rely on liquidity at the level of the asset. So if I want to price a call option with a particular strike, I don't need to worry about there being a lot of interest on the buy side and the sell side for price discovery to operate. I can just ask the AMM to flash a price for that option. And that actually is really powerful in the context of using options as building blocks, because then I can tailor my portfolio very precisely. If there's some very precise type of cash flow pattern I want to replicate, not having to rely on liquidity at the level of the asset is a very powerful tool. Okay, so now I'm just going to kind of dig into how to use options as a tool to replicate payoffs. So there is a distinction here that's worth making between composability and replication. So, they're related, but you can, do composable, you can kind of implement composability that doesn't involve replication, and you can also do replication that doesn't involve composability. Of course, you can do replication that does involve composability, so they're related. So composability is the ability to programmatically interact with third-party project contracts deployed on the blockchain. So if some project already exists that is able to create some type of asset, we can access those methods programmatically from our smart contracts. That's composability. Replication is a little different. Replication just says we can construct new asset payoff profiles by combining portfolios of other types of more primitive assets. And so the type of asset we really want to dig into as the primitive asset here are the options. Okay, so I'm just going to quickly walk through a simple example. Don't get scared. The math is very simple, trust me, and I'm just kind of using it as kind of a guidance. So I hope to be able to relay these ideas qualitatively to you as well, and then some of you who are familiar with some of these tools, you might get a little more of a rigorous explanation as well. So in what sense are options basis assets? Well, let's think of a case where we have a price that can take one of two possible values tomorrow, little s naught and little s 1. And let's consider the following two assets. One asset that pays off 1 if the price is s naught, and one asset that pays off 1 if the price is s1. These are called digital options. It turns out their payoffs span the same space as call options, and we'll come back to that. The reason that's important is because the way Arrow works is we actually just create call options, call and put options. So you need to be able to translate this logic from digital options to call options and put options. Okay, so let's see what we can build with these simple digital assets. How about a bond? Can we build a bond with a portfolio of options? It may seem counterintuitive, but it turns out this is kind of the simplest case of something that you can build with a portfolio of options. So let's define this new asset. This new asset pays 1 in each state of the world. It pays 1 if the price is s naught, and it pays 1 if the price is s1. How can we recreate these payoffs using the digital assets that we talked about? It's very simple. We just create a portfolio that has a weight 1 in the first digital asset and a weight 2 in the second digital asset. So this portfolio that has a weight 1 in the first digital asset and a weight 1 in the second digital asset replicates the payoff of the bond exactly. right? This portfolio pays off 1 in every state of the world. So let me back up a little also and just kind of talk about why bonds. They're a very simple example of things we can build with options, but I think they're also relevant for DeFi. There's a lot of interest in yield-based products in DeFi, and there's a lot of kind of debate and a lot of different ideas that people have about how to put those together, how to build those. So here's a very simple, kind of primitive-based way to build a yield product, is to use these portfolio of options to create a risk-free bond. So this price of this portfolio will be less than 1, and the portfolio will pay 1 tomorrow in every state of the world. So we can use that to back out the yield. So this portfolio of options has a yield equal to 1 over the price of the bond, and so magically we've used options to create a fixed yield product. So let me just quickly say a few things about how this price is determined. So we're assuming, again, as I mentioned in the beginning, a lot of this stuff about the AMM is very interesting, and we put a lot of work into that. But right now we're just assuming that the prices exist. So assuming the prices exist, it has to be that the price of the bond equals the price of this portfolio of options, because their payouts are identical. And you can appeal to something called no arbitrage to make that argument. So we can infer the price of the bond from this portfolio of options, and that's how we get the yield. We can generalize this a little more. So far we've abstracted from time to expiration. So we can think about, when do these digital options expire? We just assumed those ones that we were looking at, maybe they expire tomorrow. But we can say they expire at time T1. So what if we had a whole set of them? Some expire at T1, some expire at T2, some expire at T3. We can kind of reproduce this argument for forming risk-free payoffs for each of those time horizons, and we can back out a term structure. So now we can use portfolios of options formed in these clever ways to back out actually an implied term structure. And so then from this, you can build a lot more complicated yield profiles. You can actually build coupon bonds. You can very much customize the yield profile that you want. Okay, so the goal of that was to kind of quickly illustrate the points, the goal of just kind of using this two-state example, but it's not necessarily practical because, we're writing options on ETH, for example. So Ethereum takes values on the continuum. It doesn't just take 2 possible values, right? So how do we do this in practice? We need a way that works when the options are written on underliers that take values on the continuum. So there are several ways to do this, several ways to replicate a constant payout using call and put option defined over a continuous state space. So I'm just going to talk about one. It's called an overlapping spreads portfolio. So for those of you who aren't familiar, these are the payoffs of calls and puts when the underlier, in this case we're assuming the underlier takes a value on the continuum. So the call pays off, a call with a particular strike pays off the maximum of 0 and the amount by which the underlier exceeds the strike at expiration. And the put pays the maximum of 0 and the amount by which the strike exceeds the underlier at expiration. So here's a very simple combination we can form of puts and calls to give us a risk-free payout. So we just form a call spread, long K1, short K2, and a put spread, long K2, short K1. This portfolio has a constant payoff. This portfolio pays off the difference between these 2 strikes in every period. So now we've replicated the risk-free payoffs with portfolios of options defined over the continuum. And we can extend this to the case where we have multiple expirations, where we want to do something like form coupon bonds. So again, you can just take 2 different expirations here, T1 and T2. You can form these same overlapping spreads portfolios. Each of them pay off this fixed amount, and now you can back out a term structure. So in this case, to replicate a 2-period coupon bond with a 10% coupon rate and a face value of 100, we just pick K2 equals K1 plus 1, so the difference is just 1. And we form a portfolio that has weight 10 in the first overlapping spread portfolio and weight 110 in the second overlapping spread portfolio. Now we have a portfolio of options that exactly replicates the payoff of a coupon bond, a 2-period coupon bond. Okay, so can we do this in Web3? Yes, we can. So this is Arrow, just as a quick kind of snapshot of Arrow's SDK. It's up on the Avalanche testnet now. And so if you wanted to form some of these portfolios, and I do actually want to talk a little bit more about how some of these parameters are arrived at. The signature is a very important tool here, but I am running out of time, so I'll also ask people who are interested in understanding, what the role of the signature is in this API request, just to come talk to me. For now, I'll just focus on the option parameters. So here, if we just pick the ticker, say ETH, the expiration, say next week, the strikes, so here we just choose K1 and K2. The quantity, we could choose 10. And then this thing would give you one leg of the portfolio of options required to replicate the coupon bond. Okay, so that's bonds. And hopefully it was illustrative using the bonds. It is a very simple case. Those of you who have kind of seen the financial math before might think, oh, this is all trivial. It's actually, I would argue it's actually still useful, even though it definitely is the simplest case. So for those of you who are really involved in building things, building DeFi products and are interested in structured products and options and derivatives, then you can think of kind of much more complicated, customized ways to combine options using this kind of logic. So you can do calendar spreads, straddles, strangles, manage portfolios, perps, futures, swaps, and so forth. And I also just want to say something here at the end about composability. So initially I made a distinction between replication and composability. So replication is this idea that we can take some primitive basis set of assets and use them to build up kind of arbitrary cash flow profiles. Composability is the idea that we can interact with existing protocols in Web3 to actually give us the functionality or deliver the assets that we want. So you can use composability in a way that facilitates replication. So for example, you could use put-call parity to combine options you get from Arrow with underlying positions you get in swap market like Uniswap. You could also use swap, perp, and lending protocols to implement hedging portfolios given your option exposure. This is something that Arrow's hedging engine does internally. So hopefully I've piqued your interest and kind of illustrated the power of being able to use options in this way, really thinking of options as building blocks. If you are interested in building out more kind of sophisticated derivative products in Web3, you can use these as your primitive ingredients. So feel free to reach out to myself or the dev team if you have any questions about getting started with our SDK. Like I said, it's public now, and our contracts are deployed on Fuji. And with that, I think I'm out of time.